Thanks for coming so late. I'm Florian Quèze. I work for Mozilla as a performance engineer. And you might have been here last year when I was talking about the work I do. So as a performance engineer, my work is to understand how much Firefox uses power and what we can do to reduce it. So I was explaining last year how we developed power profiling tooling. And that was the cover slide. And for example, I was explaining that we have power profiling tools that let us understand how much power is used by things so small as just blinking the cursor in the address bar. So this is what I was presenting last year. And if you want to hear more on this topic, I will be doing a similar presentation, updated and extended, tomorrow in the main track. So today I will be sharing a different story. And it will be more a story, actually, because it's late and I want this presentation to be easy to follow, maybe a bit entertaining, if I can. So first a story about why I worked on power profiling my entire house, and then technical details, and then lots of examples, because those are the most interesting. So the story. So that was first time in February, and in April we had a new member in our family that I was very happy to welcome, and that completely changed our life, of course. 2 days before she was born, I installed this on the wall. One of the reasons why I installed this is solar panels, in case it's not obvious. I wanted most of her energy use to be renewable. And I tried before to have solar panels on the roof of our house, and it turned out to be extremely difficult, which means we failed to get those. Reasons were mostly there were chimneys on the south side of our house that were making massive shadows on the roof. Lots of other issues with the roof. Basically, all the companies who came, they never gave us a quote, so we couldn't get panels on the roof. So I installed this, and I was wondering, can this power the bottle warmer that we will use for the milk we give to the baby? I work from home. I work on energy efficiency all day long. Will this power my home office? So I had questions. I needed answers. So how could I answer those questions? I installed the power meter that you see here inside the electric switchboard of the house. So it's communicating with Wi-Fi and measuring 3 different things. The link with the grid, so seeing if we are importing or exporting electricity. It's measuring specifically the solar panels I had put on the wall. And it's also measuring my home office so that I could answer the questions. Of course, I very quickly came up with more questions. So I was also wondering about the washing machine, the freezer, and a few other things in the house. So this is what the thing quickly looked at. So bunch of things in here. I made the thing in the first place, so I could make a mess of it if I wanted. So now we're measuring also the link to upstairs, because there's a second panel upstairs. The freezer, the boiler, the washing machine, those kind of things. And also, I needed to answer the question, so we put a smart plug on the bottle warmer to be able to figure out what was going on there. So now let's go into technical details. What am I doing with all of this? How can I get the relevant information? So first I need to collect and store the data. Constraints I impose to myself. Nothing in the cloud, because it's very personal, sensitive data. All the power meters are connected through Wi-Fi, but with parental control, they have no internet access. They all send data through MQTT. They send 1 piece of data every second. And there's an Ubuntu virtual machine somewhere in the house that hosts an MQTT server, and with trivial scripts logs everything to disk. So that part is pretty simple. Then second part, I need to visualize the data, because if I just have massive log files, I do nothing with it. And this is where the Firefox Profiler part comes in, a tool I was very familiar with, because like the power profiling part I made the previous year. I have on the Ubuntu virtual machine a trivial node script that converts the data from the files on disk to a JSON file the profiler can understand. And the profiles contain mainly 2 things, power counters and markers. So this is what it looks like. If you're not familiar with the Profiler UI, you might not be, I will explain very briefly. So there's a time axis here. The top part here is what we call the timeline. Everything is against time. The various things I said I'm measuring, you can see them here. You see the shape of a chart for each of those. And markers, they are here, and they can give us more specific details about specific things that the script thought was interesting. And you can see here that, for example, so beam is the brand of the solar panels I put on the wall. You can see that typically it produces more in the middle of the day. You can see that whenever there's a cloud, it's less interesting. And many other things. We'll go into more details later about what we see there. Yeah, so one thing I wanted to mention here was the date, which is the most important. Sorry. The date is the most important thing here. We were 3 weeks in after we got the baby. And this is what I spent most of my days doing, and actually most of the nights too. And how this worked. Usually when people get a baby, they say they have no time left. I actually had the exact opposite. I ended up suddenly having plenty of spare time at night because she was waking up so often that we couldn't sleep, so we were taking turns, and half of the night I was up, and she would wake up, want to have some milk, and then sleep a few minutes later. So I had plenty of hacking sessions that were somewhere between 10 minutes and 3 hours. Unpredictable, but I had multiple weeks of having those sessions at night, which is why the code is maybe a bit messy, because I had to do it in small chunks. But it worked really well. Otherwise, I would have had no time to do any of this hobby project on the side. Also, the generous parental leave at Mozilla helped a lot, because that meant I had lots of those weeks where I could stay up at night and do those kind of things. And then more seriously, generating a JSON file that the profiler can understand was really simple. Maybe because I work with a profiler a lot, but still, I think most people could get it done and get something that works relatively quickly. And also, I don't have to host any web UI or anything, because I can just generate URLs like this with the URL to where I generate the JSON file, and that's all I have to handle. I don't have to take care about anything in the UI. Then there's the stuff that didn't work as well. The profiler was made to profile Firefox. Typically, we were having profiling sessions of a few seconds. I suddenly had profiles that were an entire day. So stuff didn't work so well in terms of units, for example. So I did some pull requests to add minutes and then hours. And then a few weeks later, I had days also. Changing the units, if you remember the screenshot I gave of power profiling, the cursor blinking in the address bar, we were talking about milliwatt hour, microwatt hour. Suddenly I wanted to see kilowatt hours, because numbers with many zeros were not so fun. Performance also, showing a profile that contains data for an entire day. It was not that bad, but it took like maybe 5 seconds to display. I fixed it. And another thing that was a lot more important when profiling the house, and that is completely irrelevant when profiling Firefox, is knowing when something happened. In Firefox, typically we want to know how long something took. Here I mostly wanted to know at which time of the day something happened, when we were starting to consume more power. So I also had to tweak that a little bit. It's also nicer when using the Firefox use case, but it was a lot more important for profiling the house. Colors, that was just nicer. Everything was gray in terms of power in Firefox because there were fewer tracks. And now let's go into examples. Doing laundry, washing machine, dryer. So washing, it consumes a lot of power twice, and this is most likely when heating the water. And then there's... What?
Mine only does once, and this bloke only does once. Yours is weird.
Okay. Whatever. I also wondered why it's doing it twice here. I think I saw it doing it once a few times, so depends on the program. And actually, I would like to profile the various programs. And if we zoom into this part, that looks interesting, but that we don't see because of a big thing here, we see there are lots of patterns here that are probably good enough to figure out what the machine was actually doing. And then the dryer, and it turns out it uses less power than the washing, even though it takes longer. And this is probably because we took the most efficient dryer we could find with a heat pump. And I also profiled my mother's dryer, and it uses 7 times more power than mine. Typical day at the office, home office, and this is why I don't want this data to be in the cloud, and I don't want my manager to have access to this data. We can say exactly at which second I return to my desk throughout the entire day. And you can see that there are typical days like this with small breaks in the middle. You can see the shape here is different, and then there are days like this one. And the main difference here is when you see that it's high first and then decreases, it means my battery was not full. So that means I probably work from somewhere else than my office. So here, and here, I clearly worked somewhere else than my office. And then the last one is on Sunday. So on Sunday, the only thing that remains powered on is the modem. which is also useful for Wi-Fi in the rest of the house. But maybe before working, I should have started with breakfast. So this is microwave oven from the 90s, inherited from my grandmother. And two things we typically do in the morning is unfreezing bread and heating milk. And I was surprised by the patterns there. The surprise is I was thinking that when in the unfreezing mode we would use significantly less power, and that's actually correct, but the problem is it's heating at the maximum power for a few seconds, then nothing for a little while, and every 30 seconds it's heating for 7 seconds. Which means that if I'm hoping to use solar panels, and it's in the morning, and they are not at their peak production, I'm basically buying all the power from the grid, even though the average power is only 300 watts. And that's the kind of stuff we see when power profiling with a high rate sampling, but I would not see if I was looking only at data every hour. And heating milk is what you would expect, almost a rectangle. So now time for a quiz to ensure you are still awake. In your opinion, what uses most power here? Is it the massive chest freezer we've got that's full of milk? Is it the internet modem? Who thinks the freezer? Raise your hand. Who thinks the modem?
Yeah, well, yeah, it's not summer.
So let's profile it to figure out. So, of course, very different shape. The modem is using the same amount of power almost the entire day, with very tiny variations. And the freezer, there's a spike at the beginning for a few seconds, and then it's stable for a few minutes, and then stops entirely, and then starts again. Modem, 27 watts all day long. It also runs the virtual machine that does all of those power profiling.
Yeah, I mean, mine is half.
So the answer is you were all right. They used exactly the same amount of power during the entire day.
You need a new motor.
So back to the initial question about warming the milk for the baby. So there's this milk pump, and then there's the bottle warmer. How much do each of those consume? You can just see the number. I don't need to read them out loud. Something that we quickly realized when looking at those profiles that was interesting is we see the timing. Same as figuring out when I'm working or when I'm not working. And I'm not sure if you had a baby recently and had this experience, but you have lots of constraints about how long you can keep things. So milk that has just been pumped and kept at room temperature, you can use for 4 hours. If it has gone in the fridge and you are heating it, you can use it for 2 hours. So to be able to know if the bottle of milk in front of you is usable, when suddenly the baby wakes up and you don't know when did she sleep last time because you were not in charge of her at that time, usually it's a mess. And we can make use of this data, and we did. And that's actually what we use the power metering data the most for, is figuring out if the bottle of milk in front of us is usable. And we figured this out. The reason why we figured this out is only because we could see on the chart that actually it's very easy to detect the pattern. So now it's time for a summer break. We visited my parents, and they recently had those nice solar panels installed on the roof of their kitchen, and it came with a gateway that's sending the data to the manufacturer of the gateway, who's collecting a lot of data. And I'm not too happy about that, but it was not my decision. So it's sending one data point every 15 minutes, which is good enough to figure out how much electricity was imported or exported on that day. Useless to figure out what you're actually doing with your electricity. And I noticed during one night of taking care of a baby that actually we can get one data point every second if we query a local HTTP API. So I did. Put a Raspberry Pi in there, and of course we can get profiles. So now let's see what they look like. That's what I saw at my parents' house, and one thing quickly caught my attention. So it's a three-phase system because of a large heat pump. I will go into it later. This thing looks strange. There's high power use here, and it's throughout the day. And the only thing that could be using as much power is this thing. And it's supposed to be using power off-peak hours because the price of electricity is not the same in France at night or during the day. And after investigating a little bit, we realized that there was this switch here that was in the wrong position, that was forcing the thing to be on all the time. So it was powering on whenever someone was using water. And we changed the switch, and now it's eating only around midnight, and then a little bit around 7 a.m., and then it stops the rest of the day. And that probably saved quite a bit of money. I said there's a large heat pump, so now we are no longer in the summer. Forgot to say something. The heat pump here has a large accumulator also. And when we look at the power use pattern, we see the heat pump that's pumping and using a lot of power on all the three phases 6 times a day. And then there's the circulator here that's going throughout the day. So we actually can understand how things work. And we can see also how the power from the solar panels was used. Back at home, some magic happened. I said we couldn't have solar panels on our roof, but we had a baby, which meant that we returned home, and after returning home, there was a midwife who came to visit to check everything was right. And on the car that she used to visit us, there were ads for a company putting solar panels on roofs that was owned by her husband, who's very proud of figuring out solutions to all the desperate cases where there's nothing possible, and who came, gave us a code that was very reasonable, and a couple months later, the baby solved our problem that we were not able to solve for 2 years. So now we have real solar panels on the roof. But that's enough about this part of the story. Fast forward December, and it's time for another baby picture. She's grown up quite a bit. She's really into trees. Whenever she's crying and we don't know why, we show her a tree and she's super happy. So we had to get her a nice Christmas tree for our first Christmas. And it's time for another quiz. In what you see in this picture, what's using the most power? So obviously there's the Christmas tree here. The Christmas tree turns itself on at sunset and turns off at midnight. Then, you might not have seen, but we have those solar panels here. And they produce power during the day, they use power during the night, for some reason. So, what's using the most power in your opinion? Who thinks the Christmas tree? Who thinks the solar panels? Okay, let's profile it. So, the Christmas tree uses 10 watts for a few hours here. And the solar panels, about 5 during the end of the day and the beginning of the next day. And if we look at the numbers, Christmas tree, 64. Solar panels at night, 67. That was a surprise to me. Yeah. But yeah, you couldn't be surprised twice by my quiz, I guess. But they did produce a lot more power, so it's still worth having them. And I think we still have a minute or two, so I have a few more things I can share. I have more power meters that are funnier. And the interesting thing about this one is it can give me data at a 50 Hertz sampling rate, which is the frequency of the oscillating AC power. And I forgot this profile at home on a computer that's not connected to the internet, but the profile was fun because we can see what happens whenever the rotation direction changes. We can see that there's a break in power use for a few milliseconds, and then it uses more power when the motor restarts. So all those details we can see and expose with fast sampling and power profiling. And it's pretty nice to see. And then USB power meters. Those are interesting if we want to look at the energy used by any random USB thing or anything that charges through USB. And there are quite a few in this picture. All of those are reverse engineered to make compatible with Profiler. And that's part of the topic for another talk that I will be giving tomorrow. But this is kind of how I worked with those. So reverse engineering a bit, and then putting a load, here USB light, that I knew what it would look like. The code's in here if you want to play with it. Yeah, so I will explain why this is useful for profiling Firefox on Android, and even Firefox on laptops tomorrow in the main track. Now let's see the things that were not working so well, or that I still need to look into. All the profiles I shared were looking good. I selected them. Some don't look that good. So this is a profile of a boiler. I said we profiled the boiler, so this is just, it's a gas boiler, so it's not most of the energy used, but still. During winter, it uses a lot of electricity to just circulate water, so that the hot water it's producing is going through the house. And then the Wi-Fi is not so good. It's especially terrible in our house because there's a lot of concrete with metal in it almost everywhere. Despite putting multiple repeaters, it's still not so great. And someday I still have missing data like this and profiles that are almost garbage. And it could lead to incorrect conclusions because the shape here is just clearly wrong. So if we can, wired network is probably better. It's not really possible to put those wires exactly everywhere, like on smart sockets or things like that. I think the best solution, if I have time, would be to change the firmware in those devices for an open source one and ensure that they store the data until they receive an ACK from the server that the data has been received and include timestamps in the data. So probably a project for next time I have many nights without sleep.
Yeah, exactly. More children.
I would really like to clean up this code so that others could play with it easily. It's not very complicated, but if we don't duplicate effort, that's much better. So the code for power profiling with USB meters, I cleaned up enough because it was part of my work and I put it in an easily accessible repository. The code to do profiles that are nice from on-face gateways, I would like to do soon. And the rest, it's a bit of a mess because it's a mix of my code and configuration data within the same files because, 10-minute hacking sessions. And I would also like to blog some power profiles of appliances and devices that I tested because I think there's quite a few surprises we could have when looking at devices. Some don't really behave like we would expect. And as a conclusion, I would say sampling at a high rate is useful to understand how things work, just because we are often curious. I definitely am. It's also useful to find and fix bugs, like the water heater thing at my parents that was wasting a lot of power and costing money. And if we want to optimize consumption from the power that's generated by photovoltaic panels, it's better to have an idea of how much we will consume. Like especially unfreezing bread, like I was sharing, is probably not a good candidate for using energy from solar panels. And that's all I wanted to share for today. Thanks for your attention.
3 minutes left for questions. So
Could you match the power used by your workstation with the solar panels in the end?
Oh, I forgot to say, but I could totally use the power from the solar panels for my home office because there's clearly enough, and I'm mostly working during days. And I could actually decide that when we have a lot of power from the solar panels, maybe it's time to compile Firefox. That will use a lot more power. But actually, the one thing that uses the most power, as we have seen in my profiles from the home office, is whenever I decided to use the computer without being plugged and then plug it back in, because then it charges, and that's where the power use is the biggest. The other thing that contributes a lot of power use of my office is screens. I have 2 external screens, and surprisingly, the 27 inches screen and the 20 inches screen, they have almost the same power use. So if I use only one, I could turn off the second one, and that would also save significant power.
The profiling your stuff is often called NILM, non-intrusive load monitoring. So if you go and look up there are databases you can contribute to. The end phase, be careful if you're running on version 3 and you're using production.json, it all goes away and it's all behind a paywall and horrible. Don't upgrade. And things like water, so microwaves, yes, are just on-off, so those are hard to do, so you should run them when it's sunny. And washing machines, right. So normally, washing machine is on heating the water at the beginning, and then that's it. You know, there's mechanical effort, which you could see on yours. Dishwashers are usually at least 2, because you get the main wash and then a hot rinse. So a washing machine with 2 is weird.
You could have run 2 washes.
Oh, someone snuck in and did an extra wash.
So I'm not sure if there was a question in this or if it was just comments, but about the versioning of the on-face gateway. The on-face gateway we've got at home is not collecting data about our power use. The on-face gateway we've got at home is not collecting data about our power use. So I put my own power meter behind it. And the reported data about how much power is used by the on-face system at night is dramatically different in my parents' profile and in mine, because in my parents' profile, it's the data reported by the interface gateway, and it's counting only the power used by the microinverters that are on the panel, and it's around 1 watt. And mine is also counting the power used by the gateway itself, and now we are around 5.
And I don't have that figure. And if it makes you feel better, I have very old sunny beam string inverters, and they use a few watts of that. That's fine.
So time's up. Thank you so much.
And you can see a presentation tomorrow if you want more details about Firefox Profiling.
Thank you so much.